Okay. Okay. So many thanks. Good evening, everybody, and many thanks for inviting me to this seminar. My name is Cristina Canova, and I am a professor of biostatistics and epidemiology at the University of Padova. I do research in environmental and social epidemiology, and in the last year, I've been involved in several epidemiological studies on PFAS and health effects. So this is the outline of this presentation. I will first talk about PFAS and human biomonitoring, and then I will focus on the case of the Veneto region, talking in detail about the surveillance program organized by the Regional Health Service, and some of the epidemiological evidence in the region. And then I will close with some future perspectives. So human biomonitoring, or HBM, is emerging as a crucial tool to assess environmental exposure and to support prevention strategies. It involves measuring chemical substances directly in the human body, and it is often considered the gold standard for assessing human exposure to environmental chemicals. What makes HBM particularly valuable is that it allows us to identify environmental contaminants directly in biological samples, such as blood, urine, breast milk, or hair, providing more accurate estimates of exposure compared to traditional external environmental monitoring, which relies on measurements in air, water, or soil. Another key advantage is that HBM gives a more holistic picture of exposure, because it integrates exposure coming from all possible routes, so ingestion, inhalation, dermal uptake, and from all environmental sources, including air, water, soil, dust, and food. And it reflects the combined result of toxicokinetics processes and of individual differences, capturing not only exposure levels, but when available, also early sign of biological responses. So human biomonitoring is an extremely valuable tool for environmental and health policies, because it provides quantitative information on the actual distribution of exposure in a population, supporting risk assessment and guiding public health decisions. And when combined with health surveys or courts data, HBM data can also provide opportunities to investigate the relationship between internal exposure and health effects. And this integrated approach can also help promote risk reduction measures, monitor exposure trends over time, and evaluate the effectiveness of national, regional, national, or global policies that have been implemented to reduce environmental contaminants. So going on the topic of this presentation, that is on PFAS exposure, one key reason why human biomonitoring works so well for PFAS is regards their persistence in the human body. In fact, many PFAS have a long biological half-life, roughly in the range of 2 to 8 years, which means they remain detectable for a long time in the body after the exposure. Because of this, PFAS concentrations measured in humans provide an integrated marker of longer-term body burn, The most common matrices used are serum or plasma, measured by mass spectrometry-based analytical techniques. And internal Pfas measurements have been extensively adopted in large cohorts and surveillance programs to accurately estimate Pfas exposure levels. So starting talking about what happened in the Veneto region, a chemical plant situated in Trissino, province of Vicenza. And just by chance, I am from Vicenza, in the Veneto region, began producing PFAS in the late 60s. This company was the larger producer of perfluoroalkyl compounds in the European community. And from 1968 to 2011, production involved long chain PFAS, in particularly P4. Since 2011, short chain PFAS have been produced. And for decades, the factory released wastewater into the ground with no prior treatment. And as a consequence, both surface water and groundwater became contaminated. So this slide summarizes the evolution of the Trissino plant over time. As I said, PFAS production began in 1966 when the plant was operating under the name Rimar. Later, in 1918, the company became Miteni, a joint venture between the Mitsubishi Corporation in Japan and Anikem Synthesis in Italy. And in 1996, Miteni became an affiliate of Mitsubishi Corporation. And then in 2009, the plant became part of International Chemical Investors Group. And finally, the plant was closed in 2018 after decades of production and environmental releases. So the contamination was officially discovered in March 2013. At that point, the area whose groundwater was affected was identified. And it turned out to be extremely large, 595 kilometers. And importantly, when drinking water samples were analyzed by the National Health Institution, the results clearly indicated PFOA as the main contaminant. Overall, the public water supplied in this region, in this area, cover more than 30 municipalities across 3 provinces, the province of Vicenza, of Verona, and of Padova, involving approximately 140,000 residents. And in this picture, you can see in the map of the area, and the contaminated area was called the red area, and it was divided into 2 main zones. So the red area A includes the municipalities located above the contamination plume, where both private wells and the groundwater were contaminated. Whereas in red area B, municipalities were outside the contamination plume and private wells were not contaminated. So one of the first epidemiological evidence conducted by Master Antonio and a colleague in 2018 was this ecological mortality study. Designed to explore whether the PFAS contamination could be associated with differences in mortality patterns at the municipality level. So specifically, the study compared mortality data from 1980 to 2013 across municipalities with PFAS contaminated drinking water and municipality without contaminated drinking water. And the causes of death were selected a priori, focuses on outcome that had already been suggested in the literature as potentially associated with PFAS exposure. So as you can see in this table, in males, statistically significant risk ratios were observed for all-cause mortality, as well for diabetes, cerebrovascular disease, myocardial infarction, and Alzheimer's diseases. Whereas in women, the study also reported significantly increased mortality for the same causes, and in addition for kidney cancer, breast cancer, and Parkinson's disease. Even though this was an ecological analysis, these early findings provided an important signal and contributed to the growing concern about the potential long-term health consequences of PFAS exposure in the contaminated area. So moving to a more recent evidence, this study conducted by my colleague Annibale Biggeri evaluated cause-specific mortality in red area and red area A over a longer period from 1985 to 2018. So overall, 51,621 deaths were observed compared to 47,731 expected. And the main signals were increased mortality for cardiovascular diseases, especially heart disease and ischemic heart disease, and from malignant cancer, including kidney cancer and testicular cancer. So what is particularly interesting of this study, but I can't go in detail on this, is that there was a different pattern by birth cohort and sex. And these likely reflect differences in timing, duration, and intensity of exposure. So this is an occupational mortality study conducted among almost 500 workers in Miteni exposed to P4. And in this study, a statistically significant increase in mortality was observed for all causes and for several specific outcomes, including liver cancer, liver cirrhosis, diabetes, and cancer of the lymphatic and hematopoietic tissues. Of course, the route of exposure in this cohort is different compared to the general population, but these findings provide additional evidence that occupational exposure to PFOA may be associated. So first, granular activated carbon filters, GAC filters, were introduced in water treatment facilities to reduce PFAS concentration in the drinking water supply. As a result, by 2018, most of the water samples tested showed a PFAS level below detectable limits. So in parallel, in 2017, the Veneto region launched the health surveillance program, which I will describe in detail in the next slide. So population-based screening program was offered by regional healthcare service to residents of municipalities supplied by contaminated waterworks. The program targeted individuals born between 1951 to 2014. So just the elderly people were excluded from this program for a total of approximately 106,000 residents. The invitation campaign started in January 2017, and it was organized progressively from younger to older birth cohorts. And the main aim of this plan was to the prevention of chronic metabolic, cardiovascular, or endocrine disorders related to unhealthy lifestyles and possibly to PFAS exposure. So as you can see, other specifics aim were the characterization of PFAS exposure and evaluation of health, possible health effects, the identification of unhealthy behaviors, promotion of lifestyle modification, and early detection of health problems. And a key component was the promotion of healthy lifestyles, and this include advices on smoking, alcohol consumption, diet, and physical activity. And the protocol included structured interview with healthcare professionals, collecting data on health history, sociodemographic characteristics, and along part of detailed lifestyle habits. And in addition, the surveillance visit included basic clinical assessments, such as the measurements of blood pressure and self-reported height and weight. In addition, the surveillance protocol also included a series of blood and urine tests to assess kidney function, liver enzymes, glucose metabolism, lipid profile, and thyroid function. And importantly, the program included the measurements of 12 different PFAS compounds. So, of course, PFOA, PFOS, PFNA, etc., providing a detailed picture of internal exposure in the screened population. So after this initial assessment, individuals with abnormal laboratory results or elevated PFAS concentrations relative to the distribution in the general Italian population received counseling on health behaviors when needed and were referred to their primary care physician. Whereas individual, here highlighted in red, presenting with both abnormal laboratory results and elevated PFAS levels, were invited to undergo a second level assessment, which included referral to dedicated internist and or cardiologist for further evaluation. Conducted in 3 rounds of screening. The first round started in 2017 and ended in 2023, involving a total of more than 61,000 participants, around the 57% of the invited subjects. So the second round of screening started in 2020 and is still ongoing and targeted individuals who participated. So all the participating to the first round were invited. And up to I think last week, more than 36,000 subjects participated to the second round of screening. Whereas in the third round of screening was dedicated to participants from the second round who continued to report PFAS level above the reference value, and involved by now 2,000 participants. So the same similar assessment protocol used for residents in the red area was applied to ex-workers employed at Rimar Miteni, resident also in the area. And these workers were involved in 3 screening rounds with a total of 100 workers participating in all rounds. And measured PFAS concentration in this specific population were extremely high, with the maximum level of PFAS exceeding 30,000 nanogram milliliter. So in the contaminated area, PFOA serum concentrations were, you can see them in the last row, were more than 10 times higher than those observed in highly exposed population. And as importantly, PFOA levels in this population were also much higher than those reported in the C8 study, which is one of the most well-known reference experience for PFAS exposure through drinking water. On the other hand, the concentration of the other PFAS compounds were much closer to what is typically observed in the general population, suggesting that the exposure scenario in this area was strongly dominated by PFOA. So in the study presented in these slides, that was probably the first study I was involved with my colleague Gisella Peter from the Veneto region. The main objective was to estimate the predictors of serum PFAS concentrations in order to understand which factors were driving the variability observed in the population. And the results clearly showed across, in all models that sex was the variable that explains the largest share of variance in PFAS concentrations. So overall, women tend to have lower PFAS levels than men. And this is biologically plausible because elimination is generally faster in female, mainly through menstruation, pregnancy, and child birth and breastfeeding. And these slides highlight the importance of residential history and especially the duration of residence in the red area. And in fact, the time spent in the contaminated area is one of the strongest predictors of PFAS concentrations, particularly PFOA, because it reflects cumulative exposure over the years. So other factors that have been shown contributing in PFAS variance were the time lag, meaning the time between the end of exposure. So the filters were applied in 2017, and then the interview were run later. As this time lag increases, PFAS concentrations tend to decrease, reflecting gradual elimination over time because the exposure stopped. And another relevant factors was the number of deliveries. So among women with a higher number of pregnancies and childbirth show lower PFAS levels. That is consistent with the elimination pathways during pregnancies and breastfeeding. So overall, these results suggest that PFAS concentrations are shaped not only by residential exposure history, but also by physiological factors that affect the clearance of these compounds. So when the health surveillance program had just started, the Veneto region also launched an international competitive call for research projects aimed at promoting the analysis of the data generated within the surveillance plan. So I had the opportunity to be awarded the first funded project here presented, which allowed us to produce a series of scientific findings that I will briefly present later. And this work was conducted in collaboration also with international partners, including the London School of Hygiene and Tropical Medicine and the Brown University. So the research then continued through a second project, which has only recently been completed. So the first aim of this project was to assess the relationship between serum Pfas concentrations, including later Pfas mixtures, and the range of health outcomes within the health surveillance program, while accounting for potential confounders such as anthropometric, sociodemographic, and lifestyle confounders. And the second, whenever we identify an association, we aimed for, I think, the first time in the literature to characterize its shape and evaluate if the relationship was modified by gender. And finally, we aim to estimate Pfas and in particular P4 half-life and its main determinants, and to assess the reversibility of associations identified in cross-section analysis. So in order to ensure consistency across analysis, and of course, these analyses were conducted in different time point, also with a different level of recruited, different numbers of recruited population. But we applied standardized analytical protocols using similar inclusion and exclusion criteria whenever possible. So we included participants from the first round of the health surveillance program with available information on Pfas measurements, outcome, and key covariates. Then, depending on the specific outcome, we restricted the analysis to individuals with an appropriate measurement available. And we excluded in all the analysis, or we analyzed separately pregnant women and ex-workers, and we excluded people who used medication for the specific outcome and identified. So for each main health domain available, here presented as lipid profile, blood pressure, thyroid function, metabolic syndrome, and liver enzymes, we consider all the possible clinical parameters and biomarker profiles detected in the surveillance program. Okay, so at this point, I will show in more detail only one set of results, focusing on lipid metabolism and in particularly total cholesterol. So these slides present the exposure response, adjusted exposure response curves for Pfas concentration and total cholesterol, estimated using generalized additive models, which allow to explore potential nonlinear relationships. Overall, serum concentration of P4 and Pfas were positively associated with total cholesterol and also with the LDL cholesterol. So the association appeared stronger for Pfas than P4, as shown in the C8 study. And it is also important to note that the association was approximately linear on the natural log scale of PFAS concentrations. And when we back transform this relationship to the original scale, it implies that the increase in cholesterol is more pronounced at the lower exposure levels, while the magnitude of the increase tends to attenuate as PFAS concentration became higher. So to make these results easier to interpret in a clinical point of view, we report the association across decile of exposure. And you can see here that compared with individuals in the lowest decile, the highest decile showed an average increase total cholesterol of about 9.10 milligram deciliter for P4 and 11.77 for PFOS. So these differences are clinical relevant, and because across a large population, a shift of this magnitude in total cholesterol can meaningfully contribute to cardiovascular risk. So then we move to the mixture analysis, and regarding lipids profile, the strongest mixture effects was observed for total cholesterol and LDL cholesterol, in particularly in men. Indicating that lipid outcomes were the most sensitive in the bad lipid outcomes are the most sensitive in this analysis. And looking at the compounds that contribute more in the mixture results, the PFAS that contributed the most positively to the overall effect were not P4 but PFOS and PFNA. So these findings that we see in the adults were also confirmed among children. I'm not going to present this, and also as shown in these slides among the former workers participating in the surveillance program. With association, in this case, even with even larger magnitude compared to the general resident population. And we also observed positive associations with increases in systolic and diastolic blood pressure. And overall, this supports the consistency of results across exposure scenarios and suggests strong cardiovascular-related effects at higher exposure levels. So in these very dense slides, I tried to provide a brief summary of the main outcome we investigated within the health surveillance plan. And for each outcome, you can see the corresponding publication reported. And you will find the full reference list at the end of the slide deck. And overall, the results highlighted in red represent the most consistent and robust associations observed across analysis and subgroups, particularly those related to lipid profile, blood pressure, and liver enzymes. So the first discussion regarding the analysis of the first round is that the population we analyze is truly unique because biomonitoring was offered to the entire highly exposed population rather than a small subsample. And the surveillance program includes very detailed assessment of individual exposure, key behavioral and clinical risk factors. And this provides a tailored counseling for exposure and risk reduction. So importantly, this is one of the first studies examining PFAS health outcomes association in such a large and highly exposed sample, and the first study that investigated these associations in a Mediterranean population with possible distinct lifestyle and dietary habits. So therefore, the strengths of our study are the large sample size, the possibility of adjust for a wide range of potential confounders, and the application of robust statistical methods, including different modeling strategies. On the other hand, the main limitation was the cross-sectional design, which does not allow to infer causality from the observed associations. And in addition, relying on a single PFAS measurement may not fully capture long-term exposure levels, and the findings may also be influenced by reverse causation. So given this limitation, especially the cross-sectional nature of the analysis, the next step was to move towards longitudinal perspective using the repeated measurements to better understand the dynamics over time. So one of our first longitudinal analyses aimed at better estimate the half-life of these compounds, in particularly P4. So the half-life is the time required to the concentration to decrease by half, by 50%, assuming that the exposure has stopped. And of course, it can be measured only in situations like this, where we have an hyperexposure and a cessation of exposure. So in this study, we analyzed data on subjects with more than 14 years, participating to both the round of screening, and the average time between the measurements was 4 years. So we applied the linear mixed effect model to estimate the excretion rate and half-life, correcting for background exposure. And we also tried to explore possible determinants, individual determinants of half-life, putting an interaction terms between each covariate at baseline and the time variable. So in this slide shows the change in PFAS concentration between the two measurements. And overall, the largest reduction is clearly observed for P4. In the total population, median concentration decreased from 49 nanogram milliliters to 18 nanogram milliliters, corresponding to an overall reduction of about 62%, similar in males and females. So the mean estimated P4 half-life was 2.36 years, shorter in females compared to men, consistently with the well-known routes of excretion. And half-lives varied across contributing factors. Overall, we observed faster excretion, so that means shorter half-lives in non-smokers, non-alcohol drinkers, especially among males. And finally, half-life increases with age in males, whereas it tends to decrease across age groups in female. But we need to consider that in this analysis, the population was quite young. So that's why we have these three age groups with the one just with 30 plus. So timing is running out, but I will quickly finish my presentation. I just want to add a couple of more references of research, other research group. This is regards in particularly the psychological dimension in a contaminated area, which is often overlooked. So this qualitative study conducted in this qualitative studies, semi-structure interviewed with 32 parents living in the red area were conducted. And using a grounded theory approach, three main themes emerged, describing a dynamic process over time. So first, the first phase is shock at the discovery. The second, the lifestyle change. And the third, living with PFAS in the long term, so the adaptation. And across all phases, two constant elements were uncertainty and health concern, especially regarding children. That suggests that PFAS contamination is not only an environmental and health issue, but also a chronic stressor for families, potentially leading to what the authors define as a chronic role strain. And this is another study from the same research group aimed at exploring PFAS-related health concern and satisfaction with the human biomonitoring program. Influence, if this satisfaction influence perceived quality of life among residents in the red area. So the key results is that satisfaction with the biomonitoring program was positively associated with quality of life. And the study found that higher concern about PFAS health risks were among women compared to men, and participants with the children compared to those without. And overall, this finding highlights the importance of the relational and the communicational aspects of the HBM programs, suggesting that the transparent communication, empathetic support, and community engagement may help reduce psychological distress and improve perceived well-being in contaminated communities. So looking forward, an important next steps will be the development of longitudinal epidemiological studies and in particular retrospective cohort studies using existing secondary data sources. This will allow us to generate stronger real-world epidemiological evidence in order to link PFAS exposure with the specific long-term health outcomes. And overall, combining surveillance data with real-world health records could help us move from cross-sectional associations to more robust evidence on medium and long-term effects on chronic pathologies, in particularly oncological diseases and cardiometabolic diseases. So, arigato, thank you all for your attention. I'll be happy to take a question. And as I said, you can find at the end of the slides all the references.